Hey, I'm Chris Zett from Make Everything, and today we're going to replace this piece of garbage tire carrier with something much better made from scratch. Check it out. All right, so this is a Dodge Ram 350 camper that my buddy Joe picked up, and he's going to be driving it across the country. And so he decided that the tire carrier on the back wasn't going to cut it and that he wanted to do something custom. He wants to be able to carry a water tank and a jerry can with some fuel in it along with that spare tire, but the one that was already on there had clearly been backed into a couple of poles. So we did some measurements and drew up a new one on the computer. Now, one of the key components of this is the can carrier, and so we had kind of rough dimensions, and he brought the two jerry cans and the jerry can and water can over, and I drew something over in SketchUp in 2D, and I brought it into the Torchmate software so I could cut it out of 16 gauge sheet metal over on the Torchmate plasma table. Now, I had swapped out the consumables with the precision cut consumables, and this does a really good job of cutting the sheet metal. I'm running, I think, about 100 inches per minute here, and it makes a super clean cut. And now you're going to see kind of like a tab and slot design that I had come up with for this. And it turned out to be a little bit problematic, but overall I was able to make it work. Now Joe actually picked up the material himself, so he had to have it cut down to these 2 foot by 4 foot sheets over at the metal supplier. Normally I would want to run this on a 4x4 sheet, which would have had a lot less welding and a little more just sort of bending. But we were able to make it work anyway by just kind of breaking down the project onto the 2x4 layout that we had at our disposal. Now you can see a couple of ovals and some other shapes that I cut into this, and overall the plasma cutter did a great job and left it pretty much dross free. Now we're in the back room of my shop on the Bailey magnetic brake. Now if you're not familiar with a tool like this is essentially a sheet metal brake that uses a very strong electromagnet to hold down a clamping bar and allow you to bend sheet metal in ways that you can't normally do on a regular finger brake. The capacity of this is 16 gauge mild steel, which is exactly what we're using, and it's definitely a little bit of a challenge to bend some of these wider pieces with these little spreader bars. What I found is that you want to have as much mass as you can on the material before you start to bend, so I use one of these larger bars, and essentially all I'm doing is repositioning it and lifting the bending arm so I can get the bend that I need. If we were using a traditional finger brake, you would see that that vertical leg would be getting in the way, and this would definitely be a difficult bend. Before we do any welding, we just sort of mock everything up. You can see the two cans there, and we know that everything's going to fit. Now, one of the things that I wanted on this was I wanted a slot for his straps to go, and I wanted to make sure that the slots themselves wouldn't be sharp enough to cut any strap material. Now, even a cleanly deburred piece of sheet metal can cut a strap under a real load. So what I did was I made the cut basically 3/4 of the way around, and then I used a chisel to bend over the material so that I would have this sort of hemmed seam with a folded over piece of 16 gauge metal that the strap could rest against, and I would never have to worry about it slicing a strap from a bump or from it being over tightened. Once I got the bend started, I was able to bring him over to the anvil and then just use a little bit of a hammer to get him down flat, and I think it came out pretty nice. They don't affect the size of the carrier at all, and they really, don't add any extra room that would affect the carriers, but it does allow you to make sure that you can get a strap on there without potentially cutting it. Now, I completely overestimated the size of the tabs and slot on this. Obviously, the tabs came out fine, but the slots are way, way too wide. They're about 1/4 inch wide. And with this 16 gauge material, there's just a lot of room for me to have to fill in with weld. So it didn't really turn out that great. But in the end, I was able to revise the design on the computer. So if I ever wanted to build something like this again, it would be ready to go. I squared up my corners using the ollie iron clamps. And I'm going to be using my Lincoln Powermig 140 multi-process machine for this. It's a great little machine. I've talked about it a bunch in other videos. It's a little 110 volt MIG Tig Stick machine, perfect for a hobbyist, and it'll easily weld up this 16 gauge sheet metal. I actually prefer to use this machine over some of my larger machines when I'm working on stuff like this because the gun is a little bit smaller and it is more conducive to welding this thin material. So I'm just tacking this up as I go, and I'm trying to spread that heat around, because when you're working with sheet metal like this, if you introduce a ton of heat, you're going to introduce a ton of warping. Everything cut really square on the Torchmate, and the bends turned out pretty well, but there is a little bit of tweaking that has to be done in order to make sure everything lines up properly. So I'm just tacking stuff as I go, and then cutting any welds that maybe get in the way or mess up my alignment. Now you can see my tabs are really long, but I'm able to weld them from both sides through the slot and use this 35 wire that's in my machine to fill in any gaps. I'm doing little tacks all around the piece to try to spread the heat around as best I can and reduce any possible warping. It's a pretty time-consuming process to weld sheet metal like this, because if this was thicker material, I could literally just burn in welds and make sure this thing was put together. But I'm really trying to keep this thing from getting all potato chipped and warped all over the place. Once you've added a lot of tacks, you can start doing a little bit longer welds, and I turned down my machine a little bit so that I wouldn't be introducing as much heat. This thing doesn't have to be watertight. If anything, we want it to be able to leak water so that it doesn't pool inside, but I definitely want to make sure it's very strong. Once everything welded, I bring it outside and I use a very thin flap disc and one of my Victograin grinding discs from Pferd to cut off those tabs and grind them flat. I like to use thin, like 030 cut-off discs, and I get those from Pferd as well. They're really effective, and they don't wear down the way that the traditional kind of off-the-shelf discs do. And you can see how quickly the Victograin disc is able to take down some of that heavy weld and even burn through some 16-gauge material. Knowing that the cans fit perfect is really all I needed to continue working on the rest of the rack. I'm going to be building this out of 120 wall, 1x1 steel tube. Now again, Joe had gone and picked this up from the metal supplier, so we had kind of shorter lengths than I'm used to dealing with, but it worked out fine for the application. Joe actually had worked previously at an architecture firm, so he did some drawings for this and basically had the entire thing designed before he came to the shop, which was super helpful. We had to do some field measuring, as you saw, but for the most part, we knew exactly what we wanted to, and he came with a cut list, which was super helpful and made the whole process go that much faster. The overall design is very simple, very geometric, no bends, just square 90-degree tubes, and we had left some extra room because we're not really sure how this is going to evolve over time, and we want to make sure that we're able to add different elements and different accessories to this rack in the future once he gets back from this trip. You can see how the pins in this strong hand tools table really make the fabrication of this so easy. I have these quick hold down clamps and pins keeping everything aligned. You know, there's no question as to whether or not the thing is square. It just works out so well when you use whole numbers, and you can use a table like this to make sure things lay out perfect. Once everything's tacked, I go back in and I fully weld all the seams. Now, the way the original rack was mounted was with these sort of U-bolts that bolted through the factory hinges. So I wanted to replicate them and make something that would be a little more substantial. This is some 1/4 by 1.5 inch flat stock, and I'm heating it up with my Harris Rosebud and then bending them in the Wilton vise. Once the metal's red hot, it bends super easily, but I just give it a little bit of a hammer to make sure that it gets nice and square. And then we're going to be drilling a hole straight through it so that we can get a 3/8 bolt through the hinge, which will lock this to the rear of the van. One of the other nice accessories I have is a Harris gas block, which essentially is a cutaway for the gas torch, which allows me to turn the torch off and on really quickly. I check my fit and mark them up with a Sharpie before I go over into the drill press and drill the holes. Here's a little tip: if you have to drill through a bracket like this, if you put a piece of material underneath your kind of floating edge to get through that first hole, you can allow your drill bit to pass right down through the bottom, which will give you a perfectly aligned hole in a U-shaped bracket like this. So you can see I've got that piece of angle in there, which is sort of just keeping that piece from flexing while I drill straight through the bottom. Now back outside, I can actually mount these to the back of the van, and we can then hold the rack up and try to mock it up. Now while I was inside, you can see that black tube over on the bumper. Mac and Joe had been installing this solar shower down on the rear of the van. So this thing is a pressurized aluminum tube that Joe can fill with water, and then once the sun hits it, it'll get the water nice and warm and generate some good pressure for him to do like a road shower, to wash off gear, whatever he might need. He also mounted his license plate to it, and the clearance was pretty tight on the door, but they did a good job mounting it up overall. Now the tricky thing here was I didn't want to bring my welder outside and weld this in place, so we had to hold it in place and I had to make marks with a Sharpie and then weld the hinges on back inside the shop. It was a little tricky to make sure that alignment was going to be correct, but in the end it worked out really well. Now back inside, once we knew where those hinges were going to go, we decided it was time to mount the tank carrier into this piece. So I welded in some vertical bars. Here I'm going to wind up with 2 bars, one on each side, and 1 bar sort of offset in the middle that I can put some mechanical fasteners through and some 3/8 bolts. Again, this is super simple, just 1x1 tube. It gets welded on there, and then I made it so that my tank carrier would kind of split the difference on that 1-inch tube and allow me to have a nice seam that I can throw some good weld on and make sure this thing doesn't go bouncing off when he's driving down the road. Especially since this thing is on the back of his van, we want to make sure everything about it is really, really secure, because even if something was to break or crack, it's not something that you're going to notice right away, and the last thing we want is for a water can, or even worse, a gas can or spare tire to go bouncing down the highway with him heading off in the other direction. We added some mechanical fasteners, like I said, just some 3/8 bolts, just as a little bit of a safety precaution and something that would make sure that this thing never went anywhere. While I was working on that, Macklin was cutting up some angled pieces, which would be for the tire carrier. Mac worked something up and some miters, and once we got everything kind of situated, we clamped it down to the table and welded it up. Now, we had been sort of doing this simultaneously. I was working on the welding inside while Mac and Joe were working on some stuff outside on the van, and it turned out that we had a little bit of an oversight when it came to the location of the tire carrier itself. So Mac welded up this sort of half of a hexagon, and we made it so that we could cut the miters and then cut it square in a way that it would perfectly fit on the rack. But what we didn't account for was the location of that new road shower. So me not knowing this, I welded this thing in pretty heavy inside the shop. I made sure it was perfectly aligned and we drilled the holes in it, only to find out later that it wasn't actually going to work with the road shower and it was going to need to be cut off. But that's okay. I used one of the setup blocks to make sure it was nice and square, and like I said, I burned it in pretty good because I kept thinking how horrible it would be for this thing to go bouncing off the back of his truck and roll down the highway. You can also get a shot of those hinge mounts that I made and the little 1/4-inch stop pins that I had to weld inside also, which would keep this thing from rattling and make sure it never hit the back of the truck. So here we go for our first test mount. You can see I also made a bracket on the right side, which went through some holes that were already in the door. And everything lined up really well. It was a pretty encouraging moment. We got everything mounted to the truck. And then we go to put the spare tire on once we get the cans in and realize that we're going to need to do some modifications. Now the spare tire mount would have been fine had we not added that road shower to the bumper. But at the end of the day, it wasn't too bad to fix it, and we actually wound up with 3 points, or 4 points actually, of mounting as opposed to these 2 points, which I felt a lot better about. And since Macklin measured it up, I thought that it was only appropriate for him to have to cut the old piece off and fabricate the new stuff to make sure that it worked. So Mac put in a vertical bar, and we turned that mount sideways and then put a 45-degree brace in, which wound up being way stronger than the original mount, and I'm way happier with how it came out. I just feel a lot better knowing that that heavy spare tire has multiple points versus the 2 points we originally started with. And all we basically did was raise the spare tire up so that we wouldn't have to worry about it hitting the road shower. Now, Joe was going to take this home and paint it. So what I did was recommended he use a Rust-Oleum Rusty Metal Primer, which is that sort of brownish red primer that you've seen used on metal projects before. It gets really well onto the metal, and it does a great job coating it. And then he used some Rust-Oleum flat black paint to give it a nice little paint job. He's also got this weatherproof bag that he mounts to the tire, which he's going to use for garbage. And he's got his bungee cords on there for his jerry cans. And overall, I think this thing came out really great. The door still functions properly and it looks awesome.
All right, that about does it for this video. I really enjoyed this project. It was a lot of fun. I always enjoy using the electromagnetic brake, and Joe had been talking about this for a while. We had a little bit of a hiccup with the tire mount, and all we had to do was turn that bracket and raise it up. But in the end, we were able to make it way more sturdy, which I was super happy with. Joe went ahead, like I said, and primed and painted this. We put some extra weep holes in the tank carrier, and overall I think this thing's going to hold up great. We did leave some room here on the side to add an additional tank if we want, and we left this end cap on here so that if we wanted to tie in off of this rail, we could very easily. If you enjoyed this video, please give it a thumbs up, and don't forget to subscribe to my channel for more videos like this. If you want to see what I'm doing day to day here in the shop, check me out at Make Everything Shop here on Instagram. I post pretty much every day and share my progress on projects like this along the way, kind of live, and answer questions and all that sort of stuff. Stay tuned for more videos. We got a lot of great projects going on in the shop. We have been insanely busy this summer, and I'm excited to check this one off the list and get moving on to the next thing. So don't forget to stick around and subscribe, hit the bell, smash the like, all those things. Thanks so much. See you next time. That's it.